Hey guys, Mr. Wilson here. Today we're looking at standard form number 2 notes. At the end of this video, you should be able to explain when to use each method in graphing lines, standard or slope-intercept form. And you should be able to write equations in standard form from a word problem. All right, so by now we've talked about standard form and slope-intercept form. And so we're going to now add to knowing that information to knowing when to use that information. So this section says graph each of the following lines. And so let's just get into it and we'll run into the problems we're going to run into. So first problem, we have 6x minus 3y equals 12. This is in standard form. As we approach this problem, we can graph it either way. Remember, in standard form, we find the intercepts and plot those where we only need 2 of those. Or in slope-intercept form, we want to have y by itself, identify the y-intercept, post it, and then adjust from that point using the slope. So here, I'm looking at standard form. I'm going to probably just use that. I have 6x minus 3y equals 12. Remember, standard form, we can find our x-intercept basically by covering up the y-intercept and rewriting our problem. And so I have 6x equals 12, right? That's plugging 0 in since we know that's the y coordinate for the x-intercept. Solve for x, we find that our x-intercept's at 2. Have that point. Okay, we can do the same thing with our y-intercept. Remember, basically covering up the x and the number in front of it, but not the sign in front of y. Very important here because we have negative 3y equals 12. And then solving for y, we'll divide by negative 3, so y will equal negative 4. 1, 2, 3, 4. Here's my y-intercept there. And so then that should be my line for this graph. Now there will be times where we will prefer one over the other, namely probably slope-intercept form over standard form, but we could do both in theory. Okay, so next problem. We have x plus 2y equals negative 4. Okay, this is in standard form. I'm going to keep it in standard form. Both of these numbers, 1 and 2, divide into 4 evenly. So both of my variables, my intercepts, are going to be whole numbers, and so that means we can usually work in standard form. So x, cover up the y, it just tells me x equals negative 4. Works out. Nothing I have to really think about. 1, 2, 3, 4. That's my x-intercept. Okay. I do the same thing with y. I cover up the x and not the sign in front of y. It's positive. I didn't want to cross that out. Okay. And so then we have 2y equals negative 4. Solve for y, divide by 2 on both sides. And y equals negative 2. Okay. So my y-intercept is negative 2. And now my line will go through both of those. Like that, boom. Okay. Then there's my graph. We have 5x plus 2y equals 8. Now here, as I look at this problem, I see 5 and 8. I'm going to have to divide 8 by 5 if I'm finding the x-intercept, and it's not coming out to be an even number. Okay, so here I am going to choose to either graph a fraction as my x-intercept or change this to slope-intercept form. And I'm always going to choose the one that doesn't have me graphing a fraction. So solving for y is how I'll get it to slope-intercept form. I'm subtracting 5x from both sides. That leaves me with 2y equals negative 5x plus 8. Get y all the way by itself by dividing everything by 2. And so y will equal negative 5 over 2. Remember that we want to keep that as a fraction. Plus 8 over 2 is 4. So my y-intercept is 4. 1, 2, 3, 4. My slope is negative 5 over 2, so I'll go down 5. 1, 2, 3, 4, 5 over 2. 1, 2. Okay, down 5 in the negative direction, 2 in the positive direction. 1, 2, 3, 4, 5 over 2. Okay. And so now I have that point, and I'm trying to set my ruler up so that it goes through. And so we have that line now, goes through those points. And if we were to graph or solve for our y-intercept, like our x-intercept, we would have found that x-intercept to be 8/5. That's like somewhere less than 2, but greater than 1. There's no way, I think, that we accurately post that here without this line. But the x-intercept is a constant. It remains the same, but now we aren't forced to place that point. It just happens because of the natural consequence of the line. Next problem, we have 3x equals negative, or 3x minus 9y equals 45. So here I'm looking at 3, 45, 9, 45. These are both factors of 45, so it works out. So I'm going to do 3x equals 45, divide by 3. I get x equals 15. I'll do negative 9 equals 45, divide by negative 9. And I get y equals negative 5. Okay, so as we look at it, these numbers by themselves don't seem too bad, right? They're both whole numbers. We can graph them evenly. The issue happens here. We have x is 15. Okay, given the graph, we're not going to be able to get all the way out to 15. Okay, so now, again, we're forced to 2, 3, 4, 5. 2, 3, 4, 5. We are forced, because the x-intercept won't fit on this graph, to do this in slope-intercept form. Okay, and so all that means is solving for y. So if we have 3x minus 9y equals 45, I'm going to subtract 3x from both sides. That leaves me with negative 9y equals negative 3x plus 45. And then divide everything by negative 9. Okay, so cancels out there, y. Negative 3 divided by negative 9. Negative over negative gives us positive. 3 over 9 gives us 1/3. X, okay. 45 over negative 9 gives us minus 5. Okay, and so as we do this, we already found the y-intercept to have the same y-intercepts, kind of confirmation. We probably did it right all the way through. Okay, and now our slope is 1/3. That means we go up 1 over 1, 2, 3. Up 1 over 1, 2, 3. And now that I have that set up, I'm going to just draw my line by ruler. Okay, and so now we have our line that goes through, and even though our x-intercept's way out there, this is the path that's going to get there. Okay, so what forms were each of these 4 lines in? Notice that all these 4 lines were all in standard form. When in this form, we typically use the method, use this method to graph, okay, and that's find the intercepts. For which graphs was the method difficult? It was difficult for number 3 and number 4. Okay, for number 3, it was difficult because we had a fraction intercept. And for number 4, it was difficult because we had a large number for an intercept. Okay, and so in those cases, what should we do? Use slope-intercept form. Okay, and that means we need to solve for y to put it into the form y equals mx plus b. When you solve for y, it will be in slope-intercept form. Greg can make $10 an hour mowing lawns and $8 per hour at McDonald's. Greg wants to make $200 so he can have some spending money for the weekend. Write an equation to represent this situation. Let x equal the number of hours mowing lawns and y equal the number of hours working at McDonald's. So here we go. X is mowing lawns. Y is McDonald's. Colors will help me out. Okay, so as we look at this, we are going to set this up a little bit differently than we're used to, but we know that our goal for this problem for Greg is to make $200. We know that that's what our total we want our total to be. Okay, and notice that we have 2 variables because X and Y aren't just time, it's time spent doing. X is time mowing lawns. Y is time working at McDonald's. Okay, so, and they both have numbers that go with them. Okay, if you'll notice that for McDonald's, he gets $8 per hour, and for McDonald's or mowing lawns, he gets $10 per hour. Okay, so as we look at mowing lawns, it's $10 per hour mowing lawns, and they said X is that variable, so I'm just going to use X. Okay, for McDonald's, it's $8 per hour working at McDonald's. Okay, so here's our equation. 10x plus 8y equals 200. So what's the x-intercept? Okay, so x-intercept, we cover up the y, rewrite the problem, and solve it. So we have 10x equals 200. Solve, divide by 10 on both sides. X will equal 20. What does it mean in this problem? Well, it's the number of hours needed to make $200 working only mowing lawns. Right? Because that's what X stood for. If we did, and that's what the intercepts are, is if we spent 0 hours at McDonald's, how many hours will we need to work at mowing lawns? 20 hours. Okay. What's the y-intercept? Well, we do the same thing with the y. Now, we'd have 8y, because we're covering up the x, equals 200, divide by 8, and we find y equals 2, 5. Yes. Okay. And so the y-intercept is 25. What does it mean? Numbers of hours needed to make $200 working only at McDonald's. Okay, everything's the same except now the y talks about McDonald's. Okay. D, it says it's a rainy week, so Greg was only able to mow for 4 hours. For 4 hours. How many hours does he need to work at McDonald's to reach his goal? So now we have this equation here, right? 10x plus 8y equals 200. We have this equation, but we don't have two variables anymore because we know that he only could mow for 4 hours. So now instead of 10x, we really have 10 times 4. Okay, important to make sure that you're realizing what x and y are and you're using those things correctly. So we have 40 plus 8y equals 200. Subtract 40 from both sides. We have 8y equals 160. Divide by 8. You find that y is 20. So how many hours would he need to work at McDonald's? He'd need to work 20 hours. Okay? And that's a number that makes sense. It's not like it's saying 19.3 where we have to think about what it actually means. 20 hours, whole solid number, we're good. After 5 hours at McDonald's, Greg was fed up and quit. Had those days. Okay. How many hours of mowing lawns does he need to complete to reach his goal? So same equation now, except here we're going to have to mow lawns. We don't know how many hours of that, and we know that Greg only got through 5 hours at McDonald's before he quit. Still, his goal is $200. So 8 times 5 is 40. So we got 10x equals 160, subtracting 40 from both sides. And so divide by 10, x equals 16. So he'd need to cut grass for 16 hours in order to make the money, $200 for spending money. Okay. And so that is a word problem using standard form. Okay, what standard form does is it gives us those two extremes, and then the line that's connecting them gives us all the possibilities. We'll see that visually here. In college, I had a job where I had to load softener salt into people's cars. The salt bags came in 50 pound and 80-pound bags. A customer one day asked for a ton of salt. Literally a ton. That's 2,000 pounds. Okay. Write an equation to represent all the possible combinations of salt bags that this customer could receive. So here we go. There are 50-pound bags and 80-pound bags. So as we write this equation, we say, okay, for each bag of 50-pound bags, it's 50 pounds. Plus, for each bag of 80-pound bags, it's 80 pounds. Okay, notice that these are different bags, and that's why there's different variables. These aren't linked together at all. Okay, but we know that when we're done, he's going to have a ton of salt. Now, in order to do this, we basically just solve it with slope-intercept form, where I said slope-intercept form, sorry. Now, in order to do this, we basically just solve with standard form. Find the x and y intercept. So we'll have 50x, plug 0 in for y, equals 2,000. Divide by 50. X equals, what's 2,000 divided by 50? 40. So we could have 40 50-pound bags. On the other side, if we gave them 0 50-pound bags, because we were like, let's do this in as few bags as possible, we'd have 80y equals 2,000. Divide both sides by 80. And we'd find that y equals 2,000 divided by 80, 25. Okay, and so we have 40 50-pound bags or 25 80-pound bags. So as we look at this, I'm going to make a scale so this makes sense. 15 hashes here, and we need to get up to 25. So I'm just going to say every hash is worth 2. That's my y-intercept. Okay. So for 40, all right, here are our intercepts. Our x-intercept and our y-intercept, those are the coordinates. Remember that that is 40, 0. That's where our x-intercept would be. Our y-intercept is 25 is 0, 25. Those are the points posted on the graph. And so our line that connects this, boom. All right. And so all the points through here give me the different combinations that I could have to give this man a ton of salt. Okay, it says the customer said that when he unloads the salt, he wants to make as few trips as possible from his truck to his softener in the basement. Assuming he carries one bag at a time, which combination would best suit the customer? So it seems that if he wants the fewest amount of bags, right, he's going to use the 80-pound bags. Okay, these are 80-pound bags. And these are the number of 50-pound bags. Okay, and because the 80-pound bags are only 25 bags, right? So that's what we would say he should probably do. 25 80-pound bags. As I was loading this truck, I realized I was going to run out of the 80-pound bags before he received his ton of salt. I ran out of 80-pound bags after giving him 15 bags. How many 50-pound bags do I need to give the customer to meet his order? So our equation, we had 50x plus 80y equaled 2,000. Because we only have 15 80-pound bags, that is now no longer a variable. We know what that was. But now we need to know how many 50-pound bags we're going to have to give him. So 80 times 15, that gives us 1,200. Okay, so we have 50x, subtract 1,200 from both sides, equals 800. and so that should be 16. We divide by 50 on both sides. So it needed to be 16 50-pound bags in order to get to 2,000 pounds. Okay, so now standard form word problems, and also looking at graphing and choosing between standard form and slope-intercept form. See ya.